metrics. Let's talk about Ephemeroptera, Plecoptera, and Trichoptera. The number of EPT taxa, more taxa, generally less impacted, because it's generally felt, and it's true, these do not handle habitat degradation as well as things like chironomids. And the percent EPT, higher percentage means less impacted. Don't forget, we have other fauna in here, like water mites, we have beetles, we have true flies. But these ones are considered the most sort of intolerant of degradation of your habitat. So, number of EP taxa, Ephemeroptera, Plecoptera, Trichoptera. Solomon Creek is last place. Whitehorse Creek, second last. Greg River is in second place, so it's the silver medalist here, saying we might have something good. McLeod River, again, beats everybody. Now, let's look at percent EPT. Remember what I said earlier about percent dominant taxa? Look at Whitehorse Creek. It wins percent EPT. Pretty close second, McLeod River, which had the lowest percent dominant taxa. Greg River, and then Solomon Creek. So this sort of goes back to the previous one about percent dominant taxa. Is it a mayfly? Now, this is the one I always love doing myself and with students. And actually, the EPA in the States did a study of all these sort of organizations across the country. Of course, it's the usual survey, about 30% of them replied. But this was the number one thing that everybody does for all these conservation organizations in the States. This is what everybody wants to hear about, okay? Because it was developed and modified. It provides a tolerance value for your site. So you take it, it ranges from 0, being intolerant, to 10 being highly tolerant, and our tolerance of all your taxa to organic pollution, okay? So that's fairly important. It factors in the number of specimens. So basically that's the number of specimens up here of your taxa, X, say, times the tolerance value divided by the total number of specimens in the sample, okay? Everyone follow that? So this gives you a final value between 0 and 10, with 10 being, you could probably walk across that water because it's so disgusting, versus 0 that you would probably feel you could take a drink of right away. And this was Hilsenhoff in '82 came out with this, and every publication that ever does this ever since shows this same table. So a biotic index, whether it's at the family level or the genus level, 0 to 3.5 is considered excellent. All right. 3.51 to 4.5 is considered very good, with possibly slight organic pollution. All right. And I'm not going to bore you with the rest of these. And there's a reason, you'll see. Okay. Now, here is the thing. A lot of people will say, let's do it just to the family level because it takes too much time to do it to genus, and so on. You can do it that way. You will get a result. I think you'll get a good result. But the tolerance values, if you do it at the family level for chironomids, is a 6. Okay? These are 3 of the genera you had in your samples. In this genus, the tolerance value, in other words, these guys can't handle any habitat degradation. Chironomus is bring it on. All right. This is still higher than the average. Okay. These heptageneids, these are some of the little guys I've been showing you. For a family level, the tolerance is 4. Okay. The ones you were getting in your samples, Epeorus and Erythrogena, the tolerance value is 0. So in other words, they're extremely intolerant. Again, Ephemerellidae, the average tolerance value for that family, which is what you do at the family level for this calculation, is a 1. Druniella, which were throughout, I think, all your sites, I think had Druniella, if I remember correctly, is 0. Betidae, 4. The genus Betis is a 5. You had some sites that had an awful lot of Betis. And finally, hydrocycads are considered a 4. 2 of the genera you had are a 1. So the question is, what difference will it make? There we go. So this is factoring in richness, evenness, and how tolerant these organisms are to pollutants. Okay? If you have some in this equation, if we go back here for a minute, you would enter things that are only done to family here still. You consider it a taxa and give it that standard value. Okay, so if you had some chironomids that were only identified to family, you'd enter it as a 6. All right, even doing a generic analysis. So there is your final results. Solomon Creek, based on Hilsenhoff, it has very good, and that's it. It gets lower, though, when you do it to genus. Here's where it becomes interesting. The Greg River is actually only very good if you do it at the family level. At the generic level, it's actually into the excellent water quality category. Whitehorse Creek, 3, gets down somewhat lower at the generic level. So each time, every single one, look at this. Look at the family level, McLeod River drops the most. To me, what this says is the fauna in here at the family level is very different than at the generic level. Basically, you have all the ones that are the exceptions and are lower than your actual rates here, okay, at the family level. So McLeod River, based on Hilsenhoff, wins. Now, the final thing we need to talk about, and we didn't actually have larvae so that are in this feeding niche, so we've thrown in a couple of adults. There are a couple of types of stoneflies. Percent shredders, people like to see, especially for a breakdown of leaf litter. They release dissolved organic carbon into aquatic environments, then can be used by other groups, including bacteria. Higher number reflects more carbon recycling, okay? And it's very sensitive to riparian zone impairment. So think about it, if you've basically denuded your riparian zone, you're gonna have almost no shredders, all right? So Solomon Creek has the highest percentage by far than anything else. All right, Whitehorse Creek second, McLeod River isn't even on the podium, it's so low. But what does that bank look naturally? If it doesn't have much vegetation near it, naturally, because it's all rock, you know, sort of a strewn field, it's not going to be high anyway, and that might not be relevant for you folks, okay?